addition of vectors, which is different from addition of scalar quantity. Even multiplication of vector also is a bit different. So we'll learn about multiplication of vectors. So initially start with multiplication of vector by a real number. Let's try to understand this simple example. So what would be the result if a vector a bar is multiplied by a real number, say 2. So what is 2a bar? 2a bar is equivalent to vector a plus vector a. So its magnitude gets double, direction remains unchanged. That's 2a. So if you multiply by 4, it would be a vector which is 4 times the magnitude of initial vector in the same direction. So what will be the result if multiplied by a negative number? The direction will reverse and magnitude also will change depending on the number. So in general terms we can state, if a vector a bar is multiplied by a real number m, the resulting vector is parallel to initial vector a bar if m is a positive real number, and it would be opposite in direction if m is a negative real number. It's pretty simple and commonsensical. What will happen if the vector is in component form? So vector is in form of ai cap plus bj cap plus ck cap. A, B and C are components in x, y and z direction respectively. So component form, it is equivalent to a vector A expressed as sum of 3 vectors. When we multiply this vector by some real number m, it is equivalent to each of these 3 vectors getting multiplied by m. So it will be, the resultant vector will be equal to mai cap plus mbj cap plus mck cap. And when we look at these 2 vectors, what would direction of vector be? We already seen if m is a positive number, resulting vector b will be parallel to initial vector a. So based on this, we can conclude something else as well. We arrive at condition for vectors to be parallel. If the ratio of components are same, then 2 vectors a and b are parallel. The same case here. So if what is condition for parallel? So ax divided by bx is equal to ay by by is equal to az by bz. Ratio of x component is equal to ratio of y component is equal to ratio of z component. All are equal to a constant. Other way, what we can say is vector a divided by vector b is equal to k, a constant, and we can express this kind of relationship. Actually what we written here, you have written a division of vectors. Normally we cannot divide one vector by another vector. It doesn't make sense. Only way division of vectors it makes some sense is when both the vectors a and b represent same physical quantity and both vectors are either parallel or anti-parallel. Then only you can take the ratio and is equal to k. So previous case we have seen a real number multiplied by vector. What happens if one vector is multiplied by another vector? There are 2 kinds of multiplications possible. First kind of multiplication results in a scalar quantity. When we multiply 2 vectors, result is a scalar quantity, and that kind of multiplication we call as scalar product. Another name for that is a dot product. We see the reason why it is called dot product. So what is the definition of a scalar product? The scalar product of 2 vectors is a scalar quantity equal to the product of magnitude of 2 vectors with cosine of angle between them. So it's much easier to understand in terms of equation. If 2 vectors a and b are there and there is angle theta between them. So to measure angle theta, yes, this also is vectors a and b tail to tail. So a dot b, vector a dot vector b is equal to ab cos theta. This is what this statement says, is equal to product of magnitude and cosine of the angle between the 2 vectors. A is the magnitude of first vector, b is the magnitude of second vector, and theta is the angle between them. And we denote this kind of multiplication, we use a dot sign here. That's why we call it as a dot product. So moment we see two vectors and there's a dot placed in between them, it indicates it's a multiplication but dot product of two vectors. Let's understand this result. Nothing new. Now we're going to spend more time trying to understand its application and try to understand what it will mean in different cases. So what we see here, for the same vector, as the angle changes, the dot product also will keep on changing. As the value of theta changes, cos theta will change, and accordingly the magnitude of resultant will change. Resultant is a scalar quantity. It will not have any direction. And we know the property of theta as theta keeps increasing. We know the property of cos theta as theta increases, cos theta keeps on decreasing. Hence the dot product also, as the theta increases, dot product also will keep on decreasing. Let's understand in terms of 5 distinct cases. First case, theta is equal to 0. Both vectors are in the same direction. Then the resultant or result of the dot product will be magnitude of first vector into magnitude of second vector. Maximum possible magnitude. Second is, as we start gradually increasing theta, when the theta is less than 90 degree, acute angle. So we know in case of acute angle, cos theta is positive value. Hence the result of dot product also will be positive. If we further increase the angle theta, when it is 90 degree, cos 90 is equal to 0. Hence the dot product of two vectors when the angle between them is 90 is 0. This is important property. We will find this application later. Further, if angle is obtuse angle between two vectors, that is theta greater than 90. So cos theta, when theta is greater than 90, is negative. Hence the dot product is negative. And when theta becomes 180 degree, cos 180 is minus 1. Hence the dot product is minus the product of first vector minus the product of magnitude of two vectors. So this is a minimum value when theta becomes 180 degree. In fact, reverse also is true. Initially what we have seen, if this happens, this is the result. Reverse also is true. Suppose it is mentioned the dot product is maximum. What is the angle between two vectors? 0. If the dot product is 0, what is the angle between two vectors? Angle is 90 degree. If dot product is negative, what does it imply? It implies the angle between two vectors is obtuse angle greater than 90. What happens if we reverse the order? If we here we have taken first vector as A, second vector is B. If we reverse the order, the result will be not AB cos theta will become BA cos theta. Is that different from AB cos theta? No. So basically, vector A dot vector B is equal to vector B dot vector A. If we change the order, result remains same. Basically, what we call this we call as commutative property. So scalar product obeys commutative law. Similarly, if when it is written in this form, we can open the bracket in a normal way. So this term can be written as A dot B plus A dot C vectors. So this property is called distributive property. So what does this mean? There are two ways we can find this value. One way we can find the value. First, we can find the vector sum of two vectors B and C. Then take the dot product with the vector A. Or other way is we can find the dot product between vector A and vector B. And we can find the dot product between vector A and vector C and add it up. Both will give the same result. So basically, this implies dot product or scalar product of vectors obeys distributive law. What if two vectors involved are unit vectors or dot product of unit vectors? What will be I cap dot I cap? The first vector is I cap, second vector also is I cap. The result is magnitude of first vector into magnitude of second vector into cos of angle between them. Angle is 0, so that is cos 0. Result is 1. So if two unit vectors are of same unit vectors, result is 1. Same is the case in case of j cap dot j cap or k cap dot k cap. But in case of I cap dot j cap, these two unit vectors are mutually perpendicular, hence the result will be 0. We have already seen the dot product of two vectors which are mutually perpendicular is 0. So dot product of two non-similar unit vectors will be 0. And this property we can apply in next part. If two vectors A and vector B are given in component form, this is vector A and this is vector B. What is A vector dot B vector? So in this case we can apply the distributive law. So basically this is this dot this. What does it mean? I can take the first part here and multiply with this, then this and this. So I'll take one term, I'll multiply by these terms, then the second term multiply by these three terms, and the third term multiply by these three terms. Let's understand what result would be. Let's see, first we multiply ax I cap with this, this and this. When we multiply a I cap with, say ax I cap with bx I cap. So I cap dot I cap is equal to 1, hence the result would be equal to ax bx. Next, when it is multiplied by by j cap, these two vectors are mutually perpendicular, hence result is 0. Similarly, when it is multiplied with the third component here, this result also I cap being perpendicular to k cap is 0. When you multiply this term, only one term is non-zero, other two terms are 0. Same thing will repeat in the second part also. When we multiply this with components of B, only this j component multiplied by j component will yield a non-zero product, which will be ay into by. Similarly, k component az into bj. So what is the dot product of two vectors when they are expressed in component form? X component of first vector into x component of x component into x component plus y component into y component plus z component into z component. So it's very easy to find the dot product of two vectors if they are expressed in unit vector form. So if they are expressed in component form. One very common application of dot product is work done. So work done is again a physical quantity, and work gets done when two physical quantities, that is force and displacement, interact. And when force and displacement interact, it results in third physical quantity called work done, and work done is a scalar quantity. So this is a typical example of scalar product or dot product, and this can be found experimentally or in nature also we can find example of this. So experimentally it has been found work done due to a constant force is equal to dot product of force and displacement. So I can write work done in two forms for a constant force vector dot displacement vector, or equal to fs cos theta, magnitude of force into magnitude of displacement into cos of angle between them. So either of these two, and we choose which one to use depending on which one is more suitable for a given situation. We will see that later. So a force is acting on a particle which is initially at point P, and this particle moves from point P to point Q, and as it moves from point P to Q, the force F bar remains constant. So there is a displacement when constant force F bar is acting. What is the displacement? P to Q is displacement. So displacement S vector is equal to PQ vector. If we choose the origin to be the initial position, the displacement is equal to, or S vector is equal to, position vector of Q. So then the position vector of Q is the displacement when the initial position is at the origin. But if origin is at some other point O, which is not at the initial point, in that case displacement is again PQ vector, but PQ vector we have seen in the previous cases also, the displacement is equal to final position vector minus initial position vector. So in that case, the displacement vector can be found by taking difference between final position vector and initial position vector, OQ minus OP vector. So how do you find work done? As we have seen, either I can, to find work done, either I can use this form or I can use this form. The second form, the first form, or let's call method A. If magnitude of force and displacement are given, as well as angle between them is given, then I'll use this form Fs cos theta. So all values are given. But if force and displacement are given in component form, I'll use the dot product, which we have seen in the previous screen. Dot product is equal to x component into x component plus y component into y and z component into z component. So depending on what is given, we'll use it accordingly. Yeah, let's look at some questions or numericals based on application of dot product or scalar product. We start with a simple example. A body acted upon by a force of 50 Newton is displaced through a distance of 10 meters in a direction making an angle of 60 degrees with the force. The work done by the force will be what? We have seen previously, we can calculate dot product in two ways, either magnitude of first vector into magnitude of second vector into cos theta, or in terms of rectangular components, dot product. Here, since the magnitudes are given, angle is given, directly you can apply work done is equal to Fs cos theta. F and S are magnitudes. And since both force and displacement are in SI unit, even the work done also will be in SI unit, which is equal to 250 joules. Variation of a similar question. If a particle moves from position from 2, basically this is the initial position, to a final position. So initial position vector is given, final position vector is given, and a uniform force of, this is the uniform force which is acting. If the displacement is in meter, then what is the work done? How do we calculate here? Since initial position vector and final position vector is given, first we'll find out the displacement vector, then we take the dot product between force and displacement vector, since both are given in component form. So what is displacement vector? Final position vector minus initial position vector. How do you find vector difference? X component of final position vector minus x component of initial position vector. 3 minus 2 I cap, minus 4 minus 3 j cap, and minus 1 minus of minus 3. Make there are 2 minus here, k cap. So simply we substitute the values, we find the displacement vector. Force vector is already given, so simply need to take the dot product to arrive at work done. And just to remind you, how do we take the dot product? X component multiplied by x component, y component multiplied by y component, and z component multiplied by z component, or you can call this ijk. We will use it synonymously. We substitute these values, we find the answer comes to 24 joules. Another important application of dot product or scalar product is to find the angle between two vectors which are given in component form. So here in this question we have two vectors, one is I cap plus j cap, another is j cap plus k cap. We need to find the angle between two vectors. Though we do not need to draw a diagram, but for our understanding, let's draw a graphical representation of these two vectors so that we get a mental picture of what is given here. So can we mark these two vectors on this figure here? So what we have drawn in this figure is a cube. Let's take the side of the cube equal to 1. So though it is not drawn in that fashion, each one represents side length and side is 1 unit. So this vector connects which two vertices of the cube, I cap plus j cap. That you can quite easily find out. Can you mark? Before I mark it, you should try it yourself. So this would be I cap plus j cap. Why? Quite simply, I cap plus j cap will be I cap plus j cap, or it should have a coordinate of 1 1 0. So this is the first vector. Similarly, I can mark the second vector also, j cap plus k cap. What will j cap plus k cap? Move along y-axis, then move along z-axis. Where do we reach? So A to H will be my j cap plus k cap vector. What we need to find? We need to find angle between two vectors. So these two are the diagonals on the faces of the cube. These two are the diagonals on the faces of cube. So now, since once we express both the vectors in component form, I can simply apply the formula of scalar product. Cos of angle between two vectors is equal to dot product of two vectors divided by magnitudes product. So this is a formula. We simply substitute the values. This vector dot this vector, x component multiplied by x component, 1 into 0, y component into y component is 1 into 1, 1, and z dot k component into k component, which is again 0. So dot product is 1, this magnitude is root 2, this magnitude is root 2. I substitute the values. We find cos theta is equal to 1 by 2. If cos theta is 1 by 2, theta is equal to 60 degrees. The same question can be posed in different way. Find the angle between the face diagonals of a cube from a common vertex. So both the diagonals are on the face of the cube. Let's take a question which is slightly more challenging. Angle between diagonal AG and DF of the cube as shown. The same thing can be worded in different way. Angle between two diagonals across opposite vertices of a cube. If you have to visualize, imagine that you have a cubical box. So you keep one rod across two opposite vertex and another rod across another pair of opposite vertices. What will the angle between two rods? That's what we need to find. We will draw this one. The one is across A and G, another is across D and F. To find angle, first I need to express both the vectors in component form. Can I write those things in component form? Assuming the side of the cube equal to 1, quite easy. Vector df from D to F is equivalent to moving from, I am starting from D, I am going to F. How do I go from D to F? D to A, then A to B, and B to F. So dA plus AB plus BF. I put those values. D to A is minus J plus I plus K, or H, write in the proper order. I cap minus J cap plus K cap. That is the DF vector. How about AG? Even simpler. A to G is this plus this plus this. Is I cap plus J cap plus K cap. Now to find angle is pretty simple, straightforward substitution. So cos theta is equal to dot product divided by magnitude of first vector and magnitude of the second vector. So dot product between these two quite easily can find. Dot product is 1. This magnitude is equal to root 3. This magnitude is root 3. You put the values. Cos theta is equal to 1 by 3, or angle theta between these two diagonals is equal to cos inverse of 1 by 3. Another variety of question. 3 vectors are given, A, B, C. They form sides of a triangle. For 3 vectors to form side of a triangle, either they have to be of the form of A plus B plus C is equal to 0, or sum of 2 vectors has to be equal to third vector. So here we see A plus C is equal to B. So they do form a closed triangle. Question is, what type of triangle it will form? Conceptually, how do I solve the question? How should I start thinking? To find which type of triangle, equilateral, right angle, or isosceles, what kind of triangle it forms, there are 2 ways of finding. Either I need to find the length of the sides, or I need to find the angle. Between the 2 options, finding angle is easier. And we have already seen how to find angle between 2 vectors. So it should be fairly straightforward. So either by finding the length of the side of triangle or the angle, which one is easier? Find angle between pair of side using dot product is much easier. That's what we are going to do. So if we take the using dot product, we can find angle between any pair of sides, and based on the angle we can find out what kind of triangle it forms. And this particular case, if we take side A and C or sides represented by vector A and C. If we take the dot product, it comes to 0. It means side represented by vector A is perpendicular to the side represented by vector C. It forms a right angle triangle. Again, one more question, a common kind of question based on dot product and angles. Here we need to find the angle between a vector which is given in component form. We'll check in this time, let's take in form of a variable. So this vector and the x-axis. What is the angle this vector makes with the x-axis? The concept involved is no different based on dot product. The question is, one vector is a bar. What is the second vector here? The second vector also should be along x-axis because I need to find angle with the x-axis. Hence I take the second vector as I cap. First vector is a bar, second vector is I cap. The rest all is simple substitution. So we substitute the values. So if the second vector is I cap, the dot product will be equal to ax. So other two components will be 0. So dot product is ax divided by magnitude of vector A and magnitude of vector I cap, which is 1. Magnitude of vector A is x component square plus y component square plus z component square, whole thing is square root. So this in a way becomes the formula for cos of angle with the x-axis. Similar way, it is not difficult to guess what would be the cos of angle with y-axis. All the cases you are getting cos of the angle. Cos of angle with the y-axis, everything else remains same. Only thing in place of ax, it will become ay, and in case of z-axis, it will be az. So let's take an example with the numbers. If this is a vector given and we need to find the angle it makes with the x-axis, simple substitution, and we find the cos theta is equal to 1 by 2 or theta is equal to 60 degree. So finding angle between a vector and any of the three axes is quite straightforward. Simple. Let's take one more variation. If a vector A is given in form of ai cap plus bj cap, find vectors perpendicular to vector A lying in the xy plane. So again, this involves something perpendicular, something like dot product. So first let's understand the question, what does this imply? Vector lying in xy plane. If vector is lying in xy plane, we have known if coordinates of a point are a, b, c, its position vector is ai cap plus bj cap plus c k cap. If the point is lying in xy plane, it means its z coordinate is 0 or k component is 0. That's what xy plane implies. The z coordinate is 0. It means the vector which is perpendicular to vector A will have or must have only I and j components. It should not have any k component. Because otherwise you have to think how many vectors are possible to any given vector. Infinite vectors are possible. But in a given plane, let's see how many. So what we understood, this particular line implies that vector which is perpendicular to a bar must have only I and j component. So since we do not know the vector, let's assume that vector, and that vector we assume it to be x I cap plus y j cap. And x and y are what we need to find. We have not taken k cap, where the k component is equal to 0. And since this vector must be perpendicular to vector A, its dot product with vector A must be 0. So when I take the dot product of these two, the dot product is A into x plus y into b must be equal to 0. So if we rearrange the numbers, x by y is equal to minus b by a. This term I can write in two forms. I can write is equal to minus b by a. So minus sign I take it here, or I can write b divided by minus a. So what does it mean? X could be minus b, in that case y will be a, or x could be b, in that case y will be equal to minus a. So what should be that answer? Answer is then perpendicular vector of the same magnitude is equal to If I take this minus sign here, that vector can be written as minus b into I cap plus a j cap, or it can be vector b I cap, second one, b I cap minus a j cap. And if you notice, what are these b and c vector? C vector is nothing but minus b vector. C vector is nothing but minus b vector, which makes sense. Let's we see in terms of graphical method also, we can understand what it really means. And since the components are same, magnitudes are same. A, B, C, all three have same magnitude. So we have found perpendicular vectors of same magnitude. If you have to find unit vector, perpendicular unit vector, I would have divided by its magnitude. That becomes a unit vector perpendicular to vector A. Likewise. So if we need to understand in terms of pictorial representation, let's see this is what the vector A is. That's a I cap plus b j cap. So what are the two vectors which are perpendicular to it? There are only two vectors possible which are perpendicular and lying in the plane xy. One making a anti-clockwise angle of 90, other is making clockwise angle of 90. Two vectors are opposite to each other. That's what our result is. So this is how we can visualize our answer, make sense from the answer. Similar way, if you put in terms of numbers, if a vector p is given as 3j cap minus 4k cap, which plane does this vector lie? It does not have any x component. It means x coordinate is 0. It lies in yz plane. Vector p lies in yz plane. Hence, find vectors perpendicular to this vector lying in yz plane. What would that vector? If we apply similar logic, let's understand a slightly different way. Here the component had same sign, hence perpendicular vector had opposite signs. Here the components have opposite sign, hence the perpendicular vector should have same sign. We will interchange the components and make it of the same sign. How do we interchange? So this vector, perpendicular vector, would be, this 4 becomes j component and 3 becomes k component, and both are the same sign. How do we have same sign? Either both are positive or both are negative. So that's where we can quickly find a vector perpendicular to any given vector which is lying in a plane. If the vector has same sign, perpendicular vector will have opposite sign. If the vector has opposite sign, the perpendicular vector will have same signs, and we interchange the components. Another important application of dot product, slightly tricky compared to previous questions. It requires a little better concentration. So there's a vector A given, 2i cap plus 3j cap, and there's another vector B given here. So these are two vectors. What we need to find? We need to find the component of vector A along the vector and perpendicular to vector B. We need to break this vector A in two components, not along x-axis and y-axis. This time we need to take its component along vector B and perpendicular to vector B. This is something similar to components but with slight change. So conceptually, let's see how to solve. So in case of components, if the vector makes angle theta, component along x-axis becomes magnitude of vector into cos theta, and perpendicular component becomes sin theta. So here also, if you apply similar logic, if theta is the angle between A vector and B vector, what will the component? I can represent this vector as sum of two vectors, one along B vector and one perpendicular to B vector. Essentially, we form a right angle triangle with A vector as hypotenuse and B vector parallel to B vector is one of the sides. Once we form the triangle, it should be a little simpler now. We need the length of the side, we need the direction of the side. So what is the length of the side? If angle is theta, this length will be A cos theta and this length will be equal to A sin theta. This is a triangle. Let's see how do we go about solving the question. Concept similar to resolution, form right angle triangle. So magnitude of parallel component is A cos theta. And what is the direction of parallel component? Any direction we specify in terms of unit vector. So B cap is the direction. So what is the vector? Vector is its magnitude into direction. So how do you find cos theta? So basically, first I need to find a cos theta and then need to find b cap. How to find a cos theta? Where theta is the angle between a and b vector, I will take the dot product. A dot b is equal to ab cos theta. Hence a cos theta is equal to a vector a dot vector b divided by magnitude of vector b. So what is the component parallel to? So what is parallel component? Let's call this parallel component as C. What is this parallel component? Parallel to vector B. Magnitude into direction. Magnitude is a cos theta and direction is b cap. So I can write, substitute the value of a cos theta, this value of a cos theta into b cap. This is a formula. This is a formula for component of A along B. So this is along B direction. And that's why the magnitude is also here. I can write b cap as vector B divided by its magnitude. So if I write in form of vector B, it takes this form. So either of these two formula we can keep in mind. And then what is left is substitution. We can substitute these values. A dot B is fairly simple. A dot B will be equal to 5. And square of the magnitude of B is equal to 1 square plus 1 square is equal to 2. So this is 5 by 2 multiplied by B vector, which is I cap plus J cap. This is the component which is along vector B. I call this vector as C, parallel component. How do I find the perpendicular component, which is a little more complex? So let's see what is the concept we use to find perpendicular component. Let me call the perpendicular component as D vector. By property of resolution of vector, we know that sum of the component is equal to the original vector. So C vector plus D vector is equal to A vector. I know A vector and C vector already. Hence I can find out D vector. So what is the perpendicular component? A vector minus C vector. I substitute the values. So this minus this. So 2 I cap minus 2.5 I cap. So it's equal to minus 0.5 I cap. And 3 minus 2.5 is 0.5 J cap. That's the perpendicular component. So this is the parallel component. This is the perpendicular component. We'll take up last question on the concepts based on dot product. So let's see what is given this question and let's try and understand what is given. So this question is about two vectors A1 and A2. Magnitude of first vector is 2. Magnitude of second vector also is given as 2. What is this term here? This is magnitude of resultant is given. If we take the sum of these two vectors, the magnitude of the resultant is equal to 3. Then we need to find value of this particular term. It's a dot product, very odd looking kind of thing. It looks odd, it looks complex, but it is simple. Let's see how do we solve this one. Let's use the information. The first part, what is given, let's apply this. What is this 3? The square of this is equal to square of magnitude of A1 vector and A2 vector. What is that equal to? Square of magnitude of first vector plus square of magnitude of second vector plus 2 into magnitude of first vector. So basically I am using this P square plus Q square plus 2PQ cos theta. In place of P, A1 vector, in place of Q, A2 vector. If I substitute the values, and in place of A1, A2 cos theta, I have written A1 dot A2. So this is a relationship. So basically in this relationship, I know all the values. I can find out the values of 2A1 dot A2. What is 2A1 dot A2? Rest of simple substitution. 2A1 dot A2 is equal to 1. So this is how I have made use of this part of question, this information. Now I need to find this. Let's see what this term is. This term, first I simply expand this one because I know the dot product follows distribution law. So I can open the bracket in a normal way, keeping the dot product sign in place. So first I multiply this by this. What is this equal to? 3 into A1 bar dot A1 bar. So this multiplication, we have to make sure the dot product, the dot sign is maintained here. Minus 4 A1 dot A2. I am not using the bar word. Yes, it is written here. Plus 6 into A1 dot A2 minus 8 A2 dot A2. Now we simply substitute the values. What is a1 dot a1? Is equal to square of its magnitude. So 2 into square of magnitude of a1, which is square of 2. So 3 into 4. 4 indicates this term. And this plus this is equal to, see, a1 dot a2 is equal to a2 dot a1. That's why the order we have changed here. It follows the commutative property. So this one is equal to 2 a1 dot a2, and value of 2 a1 dot a2 is equal to 1. So in place of this whole term, this is equal to 1. And what is minus a2 dot a2? Is square of magnitude of a2. The square of 2. So 8 into 2 square, that is 4. We substitute the values, I find the term is equal to minus 19. So it doesn't look so complicated. So similarly, before we finish this part, I'll leave you a small question on dot product. This also can be solved in a similar way. This is a question which is given. Here a bar and b bar are two unit vectors such that a bar plus 2b bar and 5a bar minus 4b bar are perpendicular to each other. Now, what is the angle between two vectors? Two unit vectors. And similar approach, if you can find and solve, the answer comes to 60 degrees, which you can try and solve on your own. So this completes the part related to multiplication of vectors. We have done only the dot product so far. What is left is the cross product of vector product, which we'll do next.